Alrighty, guys. Here we are. We're going to review some of the stuff that the constructions that we had in class here today. Okay, and I chose to use Pat McKernan's right here. He's got a nice sketch, so we're going to use that to demonstrate what we needed to talk about. Okay, so here we're talking about the arc length. Okay, I'm going to put that in up here so we know we're talking about arc length, right? And arc length, as you know, is a fractional part of the circumference. Okay, so we've got our circle here. The radius is, of course, subject to change. I just click on this and move it around. Got a different radius. We've got our arc length here that is subject to change. Okay, and move that around, make that change as you want. Okay, we've got our circumference. All right, and of course we know the circumference is 2 pi r. I can make the circumference larger by changing the size of the circle, right? Now, the arc length, which is the arc ABC, okay, is, as you say here, it is some fractional part of, there's our arc length formula, it is a fractional part of, okay, the entire circumference. The fraction is determined by the angle ADC, the central angle, okay, the central angle, which is also the measure of the arc, so times the radius. So here's your formula: the measure of the angle or the measure of the arc divided by 360 times the formula for the circumference will give you the arc length. We then moved into what we call the sector and the segment. Okay, the sector is essentially a slice of pie. Okay, it's a fractional part of the area of the entire circle. That's the sector. The segment is this portion, okay, which is like a capped region, and it is, as you can see, the portion that is, okay, determined by an arc and a chord. All right, so it's a portion that's determined by the arc and the chord. Today's exercise is trying to figure out how can we get that area. Now, of course, Sketchpad finds the area very easily, as is noted here. Okay, Sketchpad finds the area very easily, as was noted here. Okay, this we found we can say easily enough is a fractional part of the entire area. So we'll work that out again for you, show that how that is determined, is calculated. All right, by what? The fractional part, the angle, divided by the angle measure, 360, times the area, right? And the area is, of course, pi. Obtain your pi value here, times the radius. Pick up the radius. Radius squared. Yes, it is. Okay, so there is my area for that sector over there. The sector is given that area, okay, and that is in agreement with the area of that Sketchpad found for us. Okay, we said, well, how can you get from the area of the sector to the area of the segment? And we reasoned that what you have to do is you have to remove the area of the triangle. Okay, so the area of the triangle, of course, then you have to form the triangle. How do you have to form the triangle? Well, you got to draw the triangle, meaning whose one side is the chord, and then we drew a segment from the center of the circle perpendicular to the chord. All right, which in fact split the chord in half. And we measured that, and that's our that's the height of our triangle. So, you know, so Pat did a good job down here. He says, okay, the area of the triangle is half the height times the base, which in this case is the chord. Okay, and so we found that by formula, and it agrees with what Sketchpad found for us, regardless of how we change that or alter that. Finally, we reason that if we subtracted the area of the sector, rather say the sector area minus the triangle area, that would give us this. Sketchpad figured this area out, the segment area 546, and we lastly show by calculating that the area determined here minus the area of the triangle is equal to that same exact area of the segment. And there you have it, okay? So in order to find the area of the segment, we must first find the area of the sector and subtract out the right triangle. And of course, not right triangle, well, it could be a right triangle, and that's the next thing I was going to say, is you have to be mindful that this could be a right triangle. Of course, it will be a right triangle, which make it a little easier. If that angle were 90, that'd be a right triangle. There we go, right exactly 90. So therefore, the area of the sector segment rather would just be this, which is a quarter of a circle, less the area of the right triangle, which is this, the leg times the leg, because that's a right triangle. So you just have to say it's half the product of the two radii there. And that would give you that. More often than not, okay, you're going to that triangle in there is going to be one that you're going to recognize, okay, such as a 30, 60, 90, or it's going to have Pythagorean triplets in it. So look for those things in the exercise coming your way, okay. The segment area is the sector area minus the triangle in there, okay. Sector, of course, is a fractional part of the entire area, and the triangle area by usual means half the height times the base, but look for those special right triangles in there. There you have it, our discussion of triangle segments, sectors, and segments, and how we find their area, thanks to a nice job that Pat McKernan did there for us. Okay, there you go.